January 14th, 2005 begins with the Earth passing directly in between the Sun and Saturn, an opposition so perfect that it occurs maybe twice per millennium. Meanwhile, the Huygens probe, quietly entering the Saturnian system, is about to end its 7-year journey. As Huygens approaches, the inner planets cluster around the distant Sun. Saturn appears almost as large as Orion. A few moons are visible as white dots aligned with Saturn's rings, while Titan, its largest moon, is already well resolved. Huygens is destined for Titan, a mysterious world larger than the planet Mercury and shrouded by a thick brownish-orange atmosphere. The details of its surface have never been seen. Huygens' speed increases to near 6 kilometers per second, and Titan's disk quickly obscures our view of Saturn and its more intimate moons. As the probe enters Titan's atmosphere, the heat shield reduces the speed some 15-fold within a few minutes. The main parachute reduces the speed further. 15 minutes later, the smaller stabilizer chute allows a faster descent at first, but slows as Huygens enters the lower, denser parts of Titan's atmosphere. Huygens is approaching a dark valley between brighter, hilly regions. Beyond the hills to the left, 2 dark parallel lines appear, which are later discovered to be part of a vast system of dunes which surrounds the moon. At 21 kilometers altitude, the probe moves through a thin haze layer as seen on the horizon. The bright area near the center top is the glow of Titan's haze illuminated by the sun. A complicated system of drainage channels, some hundreds of meters wide and kilometers long, are seen cut into the hillside. These are probably the result of runoff from methane rain. Stereographic imagery reveals hills to the left to be perhaps a few hundred meters tall, while features in the valley are tens of meters in height. For most of the descent, the probe travels eastward above Titan's surface. However, below 7 kilometers altitude, the motion reverses into a backward westward motion. It reverses again at 1 kilometer altitude, and we move slowly southeastward. Hang on, as Huygens lands on Titan's surface near a water ice outcropping ridge. Another westward-looking view of the descent from 31 kilometers shows the area of Titan over which the probe has just flown. This affords us a good view of the drainage channels and apparent shoreline. More dark lowlands appear, and a rough pitted hillside to the left. Spectra of the surface suggest that the bright areas are water ice, and the darker areas are a type of hydrocarbon mixture that has never been produced in the laboratory. The small white dot in the lower center part of scene tracks our progress over Titan's surface. We see the reversal in direction at 7 kilometers altitude, and we fly over the ridge near where we will land. As we approach the surface, our perspective brings the topography to life. We see that although there are rivers and a shoreline, the basin is dry. Below, there are distinct signs of erosion which crafted the rugged ridgeline. Huygens sinks into one of these gullies. We experience a relatively soft landing on Titan's surface. The view from the surface reveals an amazingly Earth-like picture of a dry riverbed, with distant hills which are a few meters in height. Some seconds after impact, the shadow of Huygens' parachute drifts across the scene. The heat from the surface science lamp in the probe's skin vaporizes methane from Titan's surface, which is about 180 centigrade degrees below freezing. Near the probe, the ground is littered with water ice rocks and smaller pebbles which could be made of water ice, or hydrocarbons, or some combination thereof. Although we now know more than ever about this mysterious world, many questions remain unanswered. Where is the vast reservoir of liquid methane necessary to replenish the atmosphere? Where and how often does it rain on Titan? How does the methane get recirculated into the atmosphere? What materials make up the surface? What processes create and shape the hills, dunes, and valleys?